And we're back, everybody. Shout out everybody watching along at home. Hope everybody's staying healthy. So we're going to get into chapter 6. Now, just as a reminder about this week, today we're going to do section 6.1. I'm going to introduce some, so we're going to do section 6.1, and a little bit of what I had planned for tomorrow as well, because I want to leave tomorrow open. Do we all remember what we were going to do tomorrow? If you're going to retake the quiz, tomorrow in class is the time that you're going to do that, okay? So make sure you're making that decision. Make sure you're checking your grades. Also, if you have missing assignments, tomorrow is the day that you are going to get those in, okay? The only reason you should have nothing to do tomorrow is if you got a really good grade on your quiz and you have all of your assignments caught up, okay? That's the only reason that you should bring extra things to work on, like if you need to study for science or you need to, is there any quiz test tomorrow?
No. Today. By the quiz.
Well, anyway, so make sure that if you, what's that? English. Make sure that if you have things, if you have additional stuff to work on and you have everything caught up in here, make sure you bring that, okay? But I don't want you just sitting there playing video games, playing games on your computer. I want you working on something in class. I want you catching up with something. Okay? I don't give these days very often. This is just one of those days where it's easiest to try to like just do this all in one day in class. I would expect if you got less than like if you got in the 20s out of 40 on that quiz that you just took, you should definitely be retaking it, okay? I might not even make that optional. That if you got less than a 30 out of 40, if you got less than a 75% on this, then you should be retaking this quiz, okay? So be prepared for that. I might just give it to you and just say, you need to do this right now and redo this, okay? So be prepared for that. There's some of you that it's going to be a non-negotiable, like I'm just going to make you retake this quiz, that you're going to do that. Okay. But that's tomorrow. Okay, that's tomorrow. Now, everybody has their quiz back. I'm going to give you that real quick. Hold on a second. Pause. No, I lied. Everybody has their quiz, correct? Yep. Everybody got it back yesterday. Okay, good. All right, so let's talk about where we're headed next. We're headed next into chapter 6, which is all about systems of equations. Okay, systems of equations. So what is a system of equations? Well, in the last chapter, we discussed at great length how to graph a line, right? We talked about, okay, if I've got, y is equal to 2x plus 3, and I wanted to graph that, y-intercept of 3, slope of 2, there's my line, right? What we're going to do in this chapter is say, okay, what if I've got another line at y equals negative 3x minus 4, and I put it on the exact same coordinate plane. Rise 3, left 1. Rise 3, left 1. That's this chapter. We're taking two lines and putting them on the same coordinate plane and kind of investigating all that we can about that. And what we're going to do throughout the course of this chapter is find all different ways to figure out the intersection point of those two lines. Okay? Today we're going to talk about them by graphing. Later on we'll talk about by substitution, by elimination, all different algebraic methods. All right, so what I just talked about here, a system of equations is basically a set of two or more linear equations containing two or more variables. So this is kind of implying that, could I have 3 equations on the same graph? Sure. Could I have 4? Sure. Could I have 5, 6, 7? I mean, I guess if I really wanted to. When you get to Algebra 2, there's a chapter on systems of equations where you put inequality. Yes. But it's honestly not that bad. Once you know how to do 2, you'll be fine. You'll be good for as many as you want to do. Okay. So a system of linear equations is basically a set of 2 or more equations containing 2 or more variables. A solution to a system of linear equations with 2 variables is basically the ordered pair where they cross. That's really it. It's the ordered pair where the 2 lines will cross. They basically share that same point. So tell whether the ordered pair is a solution. So what do we like to do in terms of solving equations and stuff? Well, you need to be able to check your answer, right? This is like, how do you check your answer when it's a system? Well, you check your answer by seeing if it fits both equations. Let me show you what I mean here. Excuse me. I want to see, like, so somehow I got that 5, 2 was my solution. And I wanted to check that answer. We don't know how we got that yet, but we're saying, okay, somehow we got 5, 2. If I wanted to see that 5, 2 was my solution, I would plug it into equation 1 by taking 2/5 times my x value 5 minus my y value 2, and see if that equals out. Okay. Again, we should all be doing this with me, right? This is guided notes, right? I mean, I know I haven't been here in a while with the notes, but we haven't lost that, have we? Okay, 2/5 times 5 minus 2. Oh, good. It came out to be 0. So it checks out for equation 1. Now I need to see if it checks out for equation 2. 3 times 5 minus 2 is that 13. Well, 3 times 5 is 15. Does it check out for equation 2? Yes. So, is 5, 2 the intersection of these 2 lines? Yes. Okay, tell whether the ordered pair is a solution. Yes, it is a solution. What would happen if it's a no for either of the 2 equations? It would be a no. It's got to be a yes for both of them. Because if I get a no for just one of them, it's a no all around. Go ahead and try the next one on your own. Yeah.
Do you have extra mass?
I wonder if you
Do you? No, you don't need to move the equation around at all. Just plug in negative 2, 2. Just plug in negative 2, 2. It's going to be so weird that, like, when we can come back and not have to wear a mask anymore. Like, where we can actually see people say, I don't know when that's going to happen. I heard. You're saying no to that?
I'm gonna wait a minute. I'm gonna wait.
Well, the good thing for you guys is that young people, looks like you guys would be one of the last ones to get it. Because you guys are so healthy, and you're less susceptible to that. You know? Like little kids, I shouldn't say little kids, because I'm little kids, but young adults and adolescents are ones that are on the timetable of things going to get them last. You know who gets them first?
Doctors.
Yeah, doctors and healthcare professionals, like people that work at the hospitals and the nurses, they get them first. Then the elderly and like all of the really at-risk people, and then it opens up to like bigger age groups and bigger age groups and bigger age groups. Yeah. Yeah, what's up? So just plug in.
Yeah.
Why does it say?
See if that. Okay, so equation 1 here. And you're going to see me use this notation a lot. I'm going to label an equation and then I'm going to work with it. So negative 2 is x. I plug in negative 2 for x. 2 is my y value, plus 3 times it was y, so 3 times 2. Let's see if, is that a true statement?
Yeah.
This would give me negative 2 plus 6 is 4. That checks out. So it works for equation 1. Let's see if it works for equation 2. So we have negative 2, equation 2. Negative 2 plus 2 is 2. Negative, those will cancel. Uh-oh. That does not check out. Is this a solution? Is this the point where the two lines cross? No. See, that's telling me now that however I got negative 2, 2, I've done something wrong. I need to go back and fix it, okay? So we would say no for that one. So that's how to check your answer. If you're done and you're saying, okay, is this ordered pair the place where they actually cross? Okay. All solutions of a linear equation are on its graph. To find a solution of a system of linear equations, you need a point that each line has in common. In other words, you need the point of intersection, okay? Can we underline that you need their point of intersection? Okay, their point of intersection. Please don't lose sight of the end goal for the next couple sections. All we're going to do is spend time finding where these two lines will cross. That's what we're going to do. Okay, section 6.1, 6.2, 6.3, figuring out where the two lines will cross. Now, we know how to graph. We should. If we passed our last, section 5.6 to 5.8 quiz, we should know how to graph. So that should be, an easier piece. All we're going to do is put two of them on the same coordinate plane and figure out where they cross. Let's go ahead and do it. Now, here's what I would say. A lot of you guys are going to want to use colored pencils. If you'd like to. You don't have to. Okay? I will always graph in blue and red because I want you to see the difference between the two lines. And I want you to be able to separate it like that. So here's what I'm going to do. I'm always going to color code it. And I'll even write it in that color. So for my blue line, for line 1, what's my slope? What's my slope? -2. What's my y-intercept?
-1.
So now when I go to graph, everybody should be doing this with me, right? My y-intercept is -1. My slope is -2. That means I go down to right 1, down to right 1, or I could go up to left 1. Oh, it's so much easier to graph than this on my tablet. And now we're going to graph my red line. What's my slope for my red line? 1. What's my y-intercept? So I go y-intercept of 5 and a slope of 1. Okay. What's my solution to the system? What's my solution to the system? -2, 3. -2, 3. And that's literally all you have to do. Graph line 1, graph line 2, pick off the point where they cross. Now, let me ask you this. Why was this one easy to graph? Why were both of these lines easy to graph?
Because it was in standard form.
Slope-intercept form. They were in slope-intercept form, right? So that's really where the difficulty is going to come. Putting them into slope-intercept form and then graphing. So let's do that with our next one. Oh, I guess I got to go to the next slide. Is that our next one? No. It is. Oh, apparently I don't have that one. That's weird. Okay, I'll write it up there. Why don't you guys get a head start on it? Okay. So, what's wrong with my first one? It's not in slope intercept, right? So what I'm going to do is I'm going to take the time right now and solve it for y. Okay, well that's not so bad. How do I solve this for y? Yeah. Subtract 2x on both sides. So that gives me y is equal to -2x plus 9. Okay, so John, what's my slope? Oop. -2. What's my y-intercept, John?
9.
Good. So now everybody, let's graph it together. Y-intercept of 9, slope of -2, down 2, right 1. Now, I don't know where the other line is going to be yet. So I am going to make a ton of dots. Because I don't know where it's going to end up. And this one might be a good idea to like break out a ruler and graph pretty precisely. Okay, because if your line is wavy like mine tends to get, then you might miss the point where they're going to cross. The next one, the slope is 4, the y-intercept is -3. So that means we come down here at -3, and then we say slope of 4, rise 1, 2, 3, 4, run 1, rise 1, 2, 3, 4, run 1. Okay, I see the point that they have in common. 2, 5. Questions about that? Okay, let's do this last one here. Why don't you try this one on your own? Okay, so my first one here Already into slope-intercept form, perfect, already set up for me. M is 1/3, B is -3. The second one is not. Oh, well, let's graph first, I'm sorry. So the y-intercept is -3, the slope is rise 1, run 3. Or down 1, left 3. Again, I'm going to make a bunch of dots because I have no idea where this one's going to end up. And then the other line, 2x plus y is 4. Well, what's the only thing I need to do to solve for y? Good. So y is equal to -2x plus 4. Slope is -2. Y-intercept of 4. Okay, so down 2, right 1. Bingo, there it is. So my solution is 3, -2. Please don't lose sight of the end goal. The end goal is the fact that we're trying to find where the two lines will intersect. Yeah. Yeah, that's why I looked down and I was like, oh, I should print more copies. Hold on. Hey, we're not done yet. Wait, get that back out, people. Come on now. So let me kind of explain what we were just going to kind of take a day to do tomorrow. Like this Naples is the last class. They're not getting tomorrow to like retake quizzes and stuff because obviously they weren't out. So they're going to do this tomorrow. Let me show you a little bit though. We still got like 15 minutes. Perfect. Here's what I wanted to show you. You get the Desmos calculator on your OST. Okay. Have you guys worked with the Desmos calculator a little bit? That's the calculator that you always get on the OST. And let me show you. If you go Desmos, if you just search Desmos, this is probably the link that will come up. There's a little button for this calculator at all times on the test. Okay. In middle school, it was like only sometimes there, right? Depending on the certain question. In the algebra test, it's always there. You want to see something really cool? Take a look at this. Let's take that last one that we just did. Y equals 1/3 x minus 3, 2x plus y equals 4. Isn't that nice? That's like cheat code. It is really good. Like that's like, really? You get that on your OST? Like that makes these problems like, whoa,
We
so much
don't
easier.
have to simplify it. Can we just do this on the?
And that's the coolest part about this for me. Did I even need to solve this for y? No.
Can we do this on the homework?
So here's the deal. I want to see the graphs tonight. Okay, I want to see. Can you do this to kind of check your answers? Like if you're like, I'm screwing this up, I know it. I can't figure out where these lines are crossing. Break out your computer. Go to desmos.com. Okay, and just graph it real quick. Yeah. Like for example, this last one. Let's go to one more here. Let's do one more for good measure. This y plus 2x equals 9. Y is equal to 4x minus 3. Just to kind of show you one more of them. Let's delete these away. Y equals, y plus 2x plus, equals 9. Yikes. And then I'm going to enter down y equals 4x minus 3. And that's always available to you on the test. Pretty nice, right? Yeah, really nice. All right. So that's all we got for today. Let me stop the recording. I'll let you work on some homework.